Hello, statistics student. This video is for chapter 1.2, part 2. In chapter 1.2, part 1, we go over the different types of data and we do some example also. So namely, we have categorical and quantitative data. Categoricals are names or label. They're not numbers. They don't measure anything. Whereas quantitative data measure something. So in part 2, we concentrate on how we can summarize categorical data. Now, categorical data, because they are not numbers, so there's not much you can do to summarize them. You can actually find the mean of it. So here I have an example of categorical data. We have a sample of students, 12, 13 students. And the first data we collect from them is their status. Are they doing part-time or full-time? I guess depends on the number of units that you're taking. Or whether you are working. So I don't know. I think maybe 12 unit is the cutoff whether you are full-time or part-time. And then we also collect the eye color. You can see that the answer is just a category, right? The answer is not a number. So all these are this two, status of a student as well as eye colors, are both categorical data. How do I summarize them? The only way you can summarize them is to count how many are part-time in your data sets, how many is brown eyes in your data set, how many is blue eyes. So you're counting of a category. You're counting how many are full times, how many full times, 1, 2, 3, 4, like that. How many is a blue eye, 1, 2, 3, 4. So after you count it, you summarize it like this. So assume that we actually ask all the students, because we have access to the registry on all the student status. Oh, it turns out that, well, actually these are published from DVC's office registrar. They say that in spring 2020, the number of part-time students is this much. The number of full-times is this much. So these are called frequency. That means count. And that's the total number. For eye color, so just randomly say just a group of students, I think 12 students, and I have the I have the number of black, number of blue, brown, so I just count them. So this is one way of summarizing it. But we can also, so by just looking at the number, is not as good as looking at how much they are out of the total. So we are interested something called relative frequency or percentage. Relative frequency or percentage are the same thing. There is another term called, so in layman's term, we call it a percentage. And in math or in statistics, we call it a proportion if it is represented in decimal. In statistics, we usually call it relative frequency because it's relatively speaking what percentage it is out of the total. So before we go into how to calculate relative frequency, we're going to look at how to do percentage and decimal. So do some of this percent and decimal review first. So if I am to change a decimal number that represent a portion of the whole into a percentage, I do rounding, right? No, I do moving of places by move the decimal point to the right by 2 places. So 0.75 becomes 75%, 0.0178 become 1.78%, and then percentage would be, if I want to change from a percent to decimal, I move the decimal point back left by 2 places. So 25%, if I move it to 2 places, that would be 0.25, right? So I have this ready. So this move it back 1, 2, so 0.25. If it's 4%, then I do 1, 2. So I insert a 0 here, 0.04. If it's less than 1%, it's like point something of a percent, I would move still 2 places. So including the one that I have before is 0.001%, 0.001. You after you change it to the real decimal, you take off the percent. Okay. So what is percentage? Percentage is the part out of the whole. So if I want to find the percentage of full-time out of the total, I would get that count over the total. And what about the other way around? If I want to find the percent of an amount, what is the part that correspond to a certain percentage? I would need to do a multiplication. It turns out that if I want to find something of an amount, total amount, I use multiplication by changing the percent into a decimal. Say, for example, I have 1,200 students that I am interviewing or I'm surveying, and I find that 6% of them, say, take calculus. I think there's more than that. So, but what is 6% of 1,200? So 6%, to find it, I would multiply 6% by 1,200. 6% is in decimal. First of all, change to decimal is 0.06 times 1,200 is 72. And if you say, well, I spent 12% of my income on rent. So what is 12%? 12% of $2,400, $2,418 would be change 12% to 0.12 and then multiply times 2,418 is 290.16. Okay, if it is money, this is the exact value. But if 2,418 is an adult, and I want 12% of that, that is 290.16 also with no rounding. But what is the actual value if this is adult? The actual is exact value is whole number. So you would round down because 1 is less than 5. So anything that is from 0 to 4, you round down on the 10th place. If the 10th place has 5 or more, then you round up to 291. So rounding. If you need to practice this, do the math review. So now after we master all those percent calculation, we are ready to do summarize categorical data. So we say the first steps of summarizing is counting the category belongs to belongs to every category. So for example, part-time, full-time, you count the number. Now you're ready to do relative frequency. So to do relative frequency, we have the total, right? We want to know this part out of the total. So I'm going to change to using Excel. So I type the whole thing in Excel. This is the count and this is the total. So what I can do is I can just do equal 12, 5, 8, 6 divided by the total 20089. If you press enter, Excel do this for you because Excel is actually a big calculator. Anytime you start off something with equal, they know that you are doing a calculation. 6 plus 4 plus 6 plus 1, they do 7 for you. Equal, but it has to be equal, okay? 8 times 9 is 72. So they know that you are doing a calculation if you start with equal. If you just type something, 6 plus 9, they don't do anything because they don't know that you're doing calculation. It would be just like a table. So if you want to do divide, so I want to find the percentage of 7503 out of this, I would divide whatever in this category out of the total, which is 20089, right? So this is the actual number, but I will do the rounding. So 6265, it become 62.7, right? I do 2 decimal places and I want 1 decimal point. And then 373 will become 3.3734 will become 37.3 only because 4 is less than 5. Let's do another example, the eye colors. So frequencies, I only have like that many students, but I don't know the total. How do I do it? So you just do equal, just add them, right? 5 plus 1 plus 1. Oh, that's 12. So anytime you start with an equal, they will add them, and then you can add them. And then what is the relative frequency? So that would, for black, is 1 out of 12. 1 divided by 12. So that is this one. This is 4 out of 12. This is 5 out of 12. Now green is 1 out of 12. And hazel is also 1 out of 12. And then we have to do rounding, right? So the rounded number, so this would become what? 8.3%. And this becomes 33.3%, right? Because we round two places, we move two places. So the next one would be 41.7%, and this would be 8.3%, and this is 8.3%. For people that know how to do Excel, you know that actually you can convert this into percent by doing this, but that's uh, a little more complicated, so I don't want to do it. But I just want to tell you that you can actually convert this by Excel. There's a big percentage sign here. You can actually do it that way. So that's how you can change into a percentage. It is more meaningful in that you know, oh, okay, so this is 5, but 5 is what? 5 number is actually 40% of the total. Or when we say we'll have 12,000 people part-time, that is what? That's around 62%. And then full-time is 7,000. 7,000 is what? Is actually 30 something percent. So when you have a relative frequency, you can get the number more meaningful. So of course, other than summarizing with a number for each category, we can also summarize them in a graph. The graph can show a lot of other stuff. It shows the relative difference. So how much bigger is 32% out of versus 33%. So we have three graphs: bar graph, Pareto graph, and pie chart. So these two are actually the same thing. They are both pie chart. They're both bar graph. They're both bar graph where the heights represent frequency. The only difference is for Pareto graph, the highest number, the highest frequency and the lowest frequency are sorted in order. In bar graph, they are sorted in whatever order that you want, maybe whatever is given, etc. So how do I do this? You can do them by hand. You can, put the category in the bottom, write down the frequency or the relative frequency, and then write the bar. The bars usually are separated by space. And then for pie chart, you find out what percentage a particular one is, and then 50% is half of the pie, 25% is a quarter of a pie, so you can figure out how large a particular piece of a category is and write the percentage there. But Excel can actually do it automatically. So that's why I want to put this in Excel. So quickly go over how you do it. When you do the project, you will be doing this again, and you'll watch a more detailed videos. So if you want to graph the percentage and the categories together, what you can do is highlight both the frequency column and the category column. And then what you do is use insert chart, 2D chart, column chart, and that's it. Part-time, full-time. This is the graph. Okay. Maybe I'll give you more space. You can see it nicer, right? Like that. If you don't want it, you can delete it. Eye color and frequency. So now don't do the total because there's no meaning in drawing the total. Insert chart again. 2D. So you have all these different ones. And if you want Pareto chart, what you do is you move the brown in the front, right? In the table, you retype the table. So the brown is so the highest frequency is in the front, you sort them, etc., etc. If you want pie chart, you highlight them and then you do insert chart, but you don't click the bar graph, you pick the pie chart and 2D pie chart and they will show up. So when you hover over them, it will show the frequency. Okay. You should, if you're graphing them on paper, you should show the percentage as well as the frequency. Again, for eye color, insert, hover the pie chart, click 2D, and then if you go through, hover over your mouse over them, they tells you the percentage, it tells you what category it is. So that's the way to summarize categorical data. Okay, so you basically use pie chart or um, Pareto chart or um, bar graph. So the rest of it is a discussion on when is pie chart more appropriate. Pie chart is used if you want to know total out of percentage out of the total, if your total is 100%. If your total is not 100%, you do not use a pie chart. And so that's how you categorize, how you graph, categorize